Measuring the rate of reaction. 1. Hydrochloric acid reacts with solid calcium carbonate in the form of marble chips. The products of the reactions are aqueous calcium chloride, carbon dioxide gas, and water. You are to plan an investigation to find out how changes in one variable affects the rate of reaction. A1. The concentration of hydrochloric acid is one independent variable that could be investigated. Identify two other independent variables that could be investigated. We can investigate the effect of surface area. So surface area of marble chips. Surface area of marble chips. We can investigate temperature. Temperature of the hydrochloric acid. 2. How would you control each of two variables that you have identified? So in order to control the surface area, we can use same size marble chips. Or we can write down mass, same mass in all experiments. For 2, maintain a constant temperature. Using a water bath. 3. The volume of carbon dioxide produced is one dependent variable that could be measured to determine the rate of reaction. Identify another dependent variable that you could measure to determine the rate of reaction. We can measure the change in mass. Change in mass of the reaction mixture. Because there's a gas, carbon dioxide produced, which escape. So change in mass of the reaction mixture over time. As CO2 escapes. B. In order to determine how the rate of reaction between hydrochloric acid and marble chips varies with concentration of hydrochloric acid, you are provided with some marble chips and 2.00 mole per dm cube concentration of hydrochloric acid. In a series of experiments, you are to measure the time taken to collect 100 centimeter cube of carbon dioxide gas for several different concentrations of hydrochloric acid. Draw a label diagram showing the arrangement of the apparatus that could be used. So we can use gas syringe. So we need to have a conical flask. We need to have a calcium carbonate and hydrochloric acid, so marble chips. We will have a rubber bung, gas syringe. So we can use this setup. Make sure when you draw the diagram, there's no sign of gas leak. C. In each experiment, state the measurement you would need to take to allow you to determine the rate of reaction. So state the measurements allow you to determine the rate of reaction. So rate of reaction is change in concentration of reactant or product divided by time. So obviously we need, in this case, the volume of CO2 gas collected, which they have mentioned is 100 centimeter cube. We need time taken to collect 100 centimeter cube gas. We need the volume of hydrochloric acid used, and we need the concentration of hydrochloric acid. D. One of the concentration that might be used is 0.500 mole per dm cube hydrochloric acid. Describe in detail how would you use a volumetric flask to dilute 2.00 mole per dm cube hydrochloric acid to obtain 0.500 mole per dm cube hydrochloric acid. So this is a question of dilution. So how we can dilute 2 mole per dm cube to 0.500 mole per dm cube. So let's do some calculation before we start. So we can use C1 V1 is equal to C2 V2, and V1 will be equal to, so C2 is what we need to prepare is 0.500. Let's see, we want to make 100 centimeter cube of that, and we're going to start with 2.00 mole per dm cube. If I solve this, that will give me 25 centimeter cube. If I start with 25 centimeter cube and make solution up to 100, and that solution will have a concentration of 0.500 mole per dm cube. So I can say take 25 centimeter cube of 2.00 mole per dm cube HCl using a pipette, and placed in 100 centimeter cube volumetric flask. Add water to the flask to make up to the mark. And then shaken or inverted the flask several times before using. E. Explain why the amount in moles of acid used in experiments should be considerably greater than the amount in moles of calcium carbonate used. The concentration of must be such that it is the acid and not the marble chips which is controlling the rate of reaction. F. Once a range of result has been collected from the experiment, the relationship between the concentration of hydrochloric acid used and the rate of reaction should be determined by plotting a graph. Suggest which variable should be used for the axis on the graph. So we can use concentration of hydrochloric acid, concentration of HCl, and we can use 1 over T which will be rate of reaction. Two students decide to study the reaction of magnesium with dilute hydrochloric acid to find the order of this reaction with respect to acid. The equation for this reaction is magnesium solid plus hydrochloric acid aqueous gives us magnesium chloride aqueous plus hydrogen gas. The student used the following apparatus. You can see a gas syringe is used to collect the volume of hydrogen gas produced. A. Student run 5 experiments, each using a different concentration of hydrochloric acid. They use the same length of magnesium ribbon each time. 1. Why was the length of magnesium ribbon kept constant? So that is a control. So we can say to keep amount which is mole, amount of magnesium remains constant, or we can say the surface area of magnesium is constant. 2. 50 centimeter cube acid is used each time. The concentration range from 0.1 to 0.5 mole per dm cube. Calculate the maximum mass of magnesium ribbon that would completely react with acids in all 5 experiments. We can find out the moles of HCl. So N of HCl, that will be equal to concentration times by volume. Concentration, we can use the lowest one, which is 0.1. Volume is 50 divided by 1000, and if I solve this, that will give me 0.005 moles of HCl. Next, we can find out the moles of magnesium. If we can go back and look at the chemical equation, so the molar ratio between HCl and magnesium is 2:1, and if we divide the moles of HCl with 2, so 0.05 divided by 2, we can have moles of magnesium, and that will be 0.0025. To find the mass of magnesium, so mass will be equal to moles times molar mass. So mole is 0.0025 and molar mass of magnesium is 24.3. If I solve this, that will give me 0.06 gram. So we need to start with 0.06 gram of magnesium. 3. Calculate the maximum length of magnesium ribbon needed to completely react with acid in all experiment. The mass per unit length of magnesium ribbon is 1.3 times 10 to the power minus 2 gram per centimeter cube. So that means, in other words, this is density. And length will be equal to mass over density. Mass we worked out is 0.06 and density is 1.3 times 10 to the power minus 2. So if I put the units in there, so that is gram, this is gram per centimeter. So gram will cancel with gram, and if I solve this, that gave me the length in centimeter, so that will be 4.67 centimeter. B. The students predict that the reaction will be second order with respect to acid. Write the rate expression that would appropriate for this prediction. So the rate will be equal to rate constant lowercase k molar concentration of HCl to the power 2 because it is second order. C. Student plot a graph of volume of hydrogen against time. The graph of the result when the concentration of hydrochloric acid is 0.5 mole per dm cube is shown below. Draw a line of best fit on the graph. Use the line of best fit to calculate the initial rate of reaction at this concentration and give the units. Show your working. So to save some time, I have already done the line of best fit and I have drawn the tangent when time was 0. So tangent when time is 0, t is equal to 0, and then we can find out delta y over delta x. So delta y is 230, delta x is 100, and if we solve this, that will give us 2.30, and the units are centimeter cube per second. D. The student decide to measure the activation energy for the reaction. They repeat the experiment at different temperatures using a fixed concentration of an acid. The following table shows the data from the experiment. So we have ln K, which is rate constant, temperature in degrees Celsius, and that is converted into Kelvin by adding 273, and then 1 over T inverse of temperature in Kelvin. Use the data to plot a suitable graph on page 4. Draw the line of best fit. So we need to have ln K at y-axis and 1 over T on x-axis. So this is equation of straight line, like we have ln K is equal to minus EA over RT plus ln A. So ln K is equal to y, and minus EA over R is gradient, and 1 over T will be equal to X, and plus ln A is equal to C. Data for 1 over T varies from 3.47 to 2.96. So the minimum value is 2.96 and maximum is 3.47. With the ln K, so minus 3.73, and we have minus 5.46. So we need to choose a reasonable scale. So I have done this already to save some time. So on x-axis, we have 1 over T. Careful, there is 10 to the power minus 3. So when you do the calculation, you need to include that as well. And then I have drawn the triangle to find out delta y. So delta y will be equal to y2 minus y1, and delta x will be equal to x2 minus x1. So the gradient we need to find out first. Minus EA over R will be equal to gradient, and gradient will be equal to delta y over delta x, and delta y will be equal to y2 minus y1 over x2 minus x1. And if we go back and look in the graph, so y2 is equal to minus 5.50, minus 5.50, and y1 is equal to minus 3.88, minus 3.88, and x2 is equal to 3.48 times 10 to the power minus 3 minus 3.00 times 10 to the power minus 3. If I solve this, that will give me minus 1.62 divided by 0.48 times 10 to the power minus 3. Okay, EA will be equal to gradient times by gas constant R. Gradient is equal to, so minus and minus will make it plus, so 1.62 divided by 0.48 times 10 to the power minus 3 times by gas constant is 8.31. If I solve this, that will give me 28046 joule per mole. And if I convert that into kilojoules, I will divide with 1000. And if I round this to 2SF, then I will have 28 kilojoule per mole as the answer.